So welcome everyone. This talk is about Bazel, and here we are with Klaus Herling. He is a software engineer in Google since 2011. Is that right? 2011. And since last year, he has started working on Bazel. Please welcome Klaus.
Okay, so thank you very much, and thank you for the opportunity to present Bazel, the open source build system I'm involved in. And the purpose of this talk is to give you an idea of what are the ideas behind Bazel and a bit about the look and feel. So what is Bazel? Short answer, it's a build tool. That is, like Make and many other tools, it organizes how we get derived files from source files, so typically compiling stuff. It is a tool that is used at Google for over a decade, or it's a core of a tool. Google has some specific extensions compiled in. And from that, given that it's been in use at Google for so long, you can already derive that it's mainly focused at the use case we have at Google, or whenever there's a design decision to be made, it's made to better support that use case, which is you have a large single code base. So the majority of code at Google is in one big repository, and that is under active development. And basically you build everything from head all the time. So that's usually called a large monorepository, and it happens to be large at Google with tens of millions of files and tens of thousands of engineers working on it. And it is an open source since 2015, so only recently being open sourced. Okay, so why yet another build system? As mentioned already, it's optimized for large repositories. So what Bazel tries to do is to be fast, and not only by running things in parallel, but by also aggressively caching, but do so without losing correctness. That is the main focus on Bazel, to build correctly in the sense that if you now clean up everything and compile again, you get the same result that Bazel gives you with caching enabled. And the same ideally means not only functionally the same program, an equivalent program, but really byte by byte the same thing, which actually is a bit of a challenge with all the timestamps that enter this compilation all the time. Okay, and the other thing which you can deduce from the fact that it's meant for a large code base is that you go for a declarative style. So you separate the concerns of writing an application and building, how you build it. So you say, this is a C program, and have some specialized knowledge about building it. For a company like Google, that is necessary because you have specialized engineers in building an application and others who know best how to optimize for the architecture we're running our things on. And it's also generally useful to have a central point where you maintain the rules how you build your files or the derived artifacts. Okay, so how does it work? And we'll go through an example later, but the general overview is you get a target, I want to build that thing, then you read all the build files, or actually all the files you need, all the build files you need. There's nothing like recursive calling or, no recursive calling. You just read and construct the whole graph of all the dependencies you have recursively, but it's all in the same process. And from that, you decide which actions you need to do, so which invocations of compiler and so on, and then you execute it. Except if you've done the same command already with the same input, because then you don't have to do it twice. Okay, so generally generic build tool. And that's to give you a bit of feeling how the whole thing looks like. Let's go through an example. before, one of the main design features is that the repository is big, and we say we read all the build files. That can be a lot of them. And the assumption is that it's definitely true for Google. You work in the same code base for an extended amount of time and compile again, run tests, change code, run tests again. So it's worth optimizing for subsequent invocations of build and not only for the first one. And therefore, to not compute the whole dependency graph over and over again, Bazel has a client-server architecture that is, once you start Bazel for the first time in a working directory on a code base, it will start a server in the background that constructs the dependency graph and keeps it in memory. And once you ask for another build or another test in the same working directory, in the same checkout, basically, same workspace, then the information will already be in memory and only updated with changes made to the files since you last invoked Bazel. And that's also how we can handle the whole dependency graph in memory and read everything without losing too much time on pre-computing all the, on computing the build graph over and over again. Okay, but as I said, declarative style, how does it look? Let's look at a simple example. We want to write hello world, which is a simple program, except to demonstrate a point, I choose to call a library, make a call to a library. So this program depends on a library, as it is usual with also bigger pieces of software. And in this case, a simple C library, so you have a header file, and you have an implementation. Okay, that could be a typical, well, part of the source tree, but it shows already all the relevant parts. In that simple case, and now we want to tell Bazel how to build something useful from that. The first thing is we have a workspace file, which in that simple example, and in actually many examples, is just an empty file. It serves two purposes. On the one hand, to give the border of the code base and a reference point where all absolute paths or absolute names of targets to be built refer to. And it also allows to specify external dependencies that are built in, so external repositories. As said, Bazel wants to construct the whole graph, so it also needs about external repositories that are part of the build. But for the main use case that you have everything in a big repository, you won't have external repositories. So very often it's this empty file just to get the namespace clear. And then you have the actual build files. In this case, you have a library, start from the top. Next to the C program, you have a build file saying, look, I have a binary, it's written in C. It has a name, this is the source file, and by the way, it depends on that library. And for the library, it's similar, say this is a library, it has a name, and all the C files in that directory are my source files, and all the header files belong to that library. So the important thing to notice is what is not in that build file. And this is all the details about what is my C tool chain, do I do a cross-compilation or not, what is my source and target architecture. That all is specified elsewhere, or you use for C there is also some knowledge built in. And the whole point is you don't have to specify it at each invocation of the compiler, but at a separate place. Okay, so now let's try to build hello world and see what happens. The first thing is we want to build a target, so we need to know what the target is. From the namespace, we see it's in the top level package, so we say, okay, we need to know about that package, and then we actually find the build file and read it. Once we know, then in that build file we see, okay, it's a C binary. We discover dependencies. There are two declared dependencies. One is the source file, and the other is the library. Okay, now we need to build a library. And before doing that, again, the important thing is what is not shown on the slide. Bazel also implicitly records which toolchain it is building things for. So if you later change that, it knows that all the binaries have to be rebuilt again. Okay, but then the library is also straightforward. It's found in a package, so you read the build file in that directory. And as already mentioned, the whole dependency graph is built at once and kept in memory in the server. Okay, then you see glop expressions, which means you have to really read the content of the directory. You discover the files you need. And now you've discovered all the things you need for your build. Then you can evaluate the rules and know which actions you have to perform, so which compilation steps. In this case, you compile the C file to an object, build a library, compile the other binary, compile the other C file, and then link everything together. So this is the graph that is actually productive. This is how we get to derived files from source files. These are the actions. But the important thing is there are all the other dependent things we read during the planning of the execution, and we need to keep track of in order to discover if something changes. And that's what Bazel does. It really records all the dependencies, not only those that are source files. For example, if we add a file to that directory, just simply adding the file, then of course nothing has changed with the targets we've built, but we discovered that the content of the directory has changed. And by discover, I actually mean on operating system where that's possible, Bazel tries to be notified by the operating system about changes, but it can always fall back to restarting everything. We definitely try to avoid reading all the files again, but actively try to find out what's changed. In any case, the contents of the directory has changed, which means the whole part of the graph gets invalidated. Everything that's not very visible there. So basically, the directory has changed, so everything that is reachable from here needs to be redone. Yeah.
Sorry, I'm waiting for my friend to ask you a question.
Okay, sorry. Okay, so yeah, that's not very visible. But basically, since we discovered that, that a large part of the graph is invalid, we walk through the graph again, and once we hit the library rule, we see that since the content of the directory has changed, we need to extend the action graph so differently, so we add the missing parts of the action graph, and then we know what needs to be done again. So again, the point I'm trying to make is that by really recording everything that went into that build, we can detect changes and don't have to, we're not missing updates, so we can rely on it being correct, so we don't have to clean everything and start all over again. Okay, so actions. As already mentioned, these are the productive part. These are invocations of compilers and linkers and so on. So they actually do something, they generate artifacts, and hence take the biggest part of the time of the system. So that's why it's particularly interesting in avoiding redoing them again. So we've seen the dependency graph and shows when something has changed and we need to redo it again. But there's also caching of actions themselves in the sense that if the input hasn't changed, we don't need to redo the action, we know the output will be the same, so we don't do it. Of course, for that to work correctly, Bazel needs to know all the inputs and all the outputs of an action. And not on, so Bazel needs full knowledge about that, because if you read more files than you declare, you might accidentally hit, or you might not redo an action that needs to be redone. So conceptually, that means there are nodes such done something targets where you have an empty file. saying, yeah, I've done all the prerequisites for a task, but you actually do declare all the inputs and outputs that go into a target. And all your actions are supposed to only read the input that are declared. Now suppose that sounds like a huge burden on the person writing the build file. Well, there is some tools that help. Bazel has built in a concept of a sandbox to make it easier to write correct build files, which only access the input they declare. And so by a sandbox, that's basically an isolation environment where only the declared inputs and the declared tools of an action are present, and where only the declared outputs are moved out. Depending on the operating system, that can be implemented in a different way. It could be a change root, or is. There's also the implementation where you just make a temporary directory link, a symlink in everything you need and nothing else. So that is not a security feature. It's just a tool to help you detect incorrect declarations in your build file. And for that, it works really reliable. And the other advantage of having full knowledge of all your input and output files is that you can send then an action to be executed to a remote place. So you don't have to build everything on your own workstation. You can use a build cluster if you happen to have one. And that, using a build cluster with fully declared inputs and outputs, is really powerful in a situation like Google, where basically everyone works on the same code base, because that allows having a cache that is between different developers. So not only not compiling a file if you already compiled it, but if someone else working on the same code base did it. Because then the shared remote execution will tell you, I know the answer, that is it. And as I said, so if a lot of people work on the same code base, that can save a lot of time and be very efficient. Okay, that's the general idea of how Bazel works, and now I've shown C program. What about other languages? So first of all, Bazel has specialized knowledge about a lot of programming languages, including C, C++, Java, Python, and a bunch of others. It also has generic rules, in particular a rule called gen rule, which is, well, generically to generate artifacts. It's basically just, no, it is a shell command. You say, execute that shell command from these inputs and outputs, and to help you specify the shell command, you have variables that might look familiar. It's $add, $less, and so on. So that rule should look pretty familiar. Basically, it's the only rule you have to make files. But at least it means you're generically enough to build arbitrary things, because make can do that. And in Unix, everything is a shell command, so you can build it. Nevertheless, as I mentioned, that the idea is to have a central declarative place about how to build things. So, yes, for every language, you want a central place where you have the knowledge of how to build things. And it doesn't scale to add all that information into Bazel, because there are more and more programming languages and so on coming up over and over again. I mean, it worked as long as it was a tool just for one company, where you knew all the languages you had and could add and control the tool yourself. But in general, that's not a good approach to add specialized knowledge of each and every language in the world into a single tool. So that's why there's a need for a way to extend the build files, but there actually is one. And that's called Skylark. It's an extension language. It has a syntax that looks quite similar to Python, and also semantic is quite similar. But it's basically Python restricted to some core where you don't have too far-reaching side effects, so that you can evaluate things locally, don't need global state, and have at least the declaration of what you want to build in a very insulated way. Yes, and of course deterministic, because you deterministically want what you need. So in the simple case, and as I hinted on the general, that is quite a generic case already, is that you can code up the knowledge how to build your language that isn't built into Bazel, or describe how to compile that language by means of already existing rules. I mean, it could be just generals all over the place. So that typical example, yes, to build that language, you just have to run that shell script, and by the way, you have several targets for, I don't know, the binary and binary. Or just from that source, you can derive several targets. So the typical example is documentation. You have your whatever RST file, and then you create a man page, a web page, and so on. And they want to have in one rule, and you have commands for that. So that would be the case. Yes, here's a general, and I generate these 5 things from that source file. And whenever I write that declarative style, please add all the rules to build those things. And here's an example how such a thing looked like. And as promised, the language really looks like Python, including all the things that you can pass parameters by name and not only positional, which is very useful. You can add default values for parameters. You can do some simple computations. And then you can, you can map it to already existing rules, like the general, which is a native rule. And yeah, so simple enough. And as hinted, you can even, the typical case, not only do some computations on the parameter to set up your command and set all the environment correctly, and then map to native rules. You can also do that conditionally depending on parameters, or you can map to multiple native rules so that by one declaration you declare a bunch of targets that semantically belong together. So you write such an extension in a separate file with the ending .bzl, and then in your build file, or in every build file that needs that extension, you load it by saying this is the file where the extension is described, and specifying the symbols you want to import from that file, so that by reading a build file, you actually know what is in your namespace and not suddenly accidentally declare commands you're not aware of. And I don't have an example for that, but Skylak also has full access to the action interface. So in the more complicated cases, you can really not only refer to native rules, but specify actions in detail, including all the things that native rules can do, like checking parameters for types, checking that parameters are present, and these kind of things. So I won't go into more details of Skylak. Instead, I'll answer the question that comes up occasionally is, why did it take so long? Or why does the whole process of open sourcing take so long? I said, yes, it was open source 2015, and in a sense it's still going on. There are still some tests which are not open source. There's some functionality which we intend to have open source, but is not there yet. And there is to remember that it's only became an open source project after a lot of years of internal usage on a single repository. I mean, a large one, but a single one. And in fact, it's, as I said, Bazel is not a fork of the tool used at Google. It is the same tool, just Google has some extensions compiled in. So that also means that everything has to work all the time, also for the non-published use cases. Google can't afford to not have their engineers build software for an extended period of time. But once you have but from that history that it used for years only for an internal use case, a lot of properties of the code base arose which made it hard to open source it or still blocked open sourcing some tests. The one is if you have all one huge code base with a lot of useful libraries, you tend to use them. So you have a lot of dependencies, including libraries that solve a problem that also open source libraries would solve, but they are Google specific, internal technology and so on. And of course, if you want to make a tool open source, you need all the dependencies open source. So cutting dependencies or finding replacement libraries is a big task. Yeah, so internally you have all the libraries, so it's just easy to use them, so you do it. And historically, as there was this only code base, there was a big focus on these languages that are widely used at Google. So the whole extension interface, Skylab, is something that only very late in the process came. And also still there's a bit of focus on the built-in languages, and we're trying to remove that and make it a generic tool. Oh yeah, and if you have a large code base, then it's very easy to, or if you have only the one code base where things are supposed to work and where you build everything from, then you have the advantage that for all interfaces you know all the call sites, so you can change it easily. Which is not that nice for an open source project if things change all the time. And of course, if it wasn't intended originally as an open source project, so you find hard-coded paths everywhere, and a lot of things that are all easy to fix, but in some, that's why it takes such a while to get it open source. Yeah, I just know what my compiler is, and a lot of small details like that. That's why the process of open sourcing is still in parts going on, even so what is open source is a useful tool in its own right. And yeah, and that brings me to the roadmap, where is Bazel trying to move to. So the big goal is Bazel 1.0, and I think on our roadmap we currently say we want to be there sometime next year, hopefully. What does it mean? So the first thing is we want the public repository to be the primary one. At the moment, the Google internal repository is the primary one, and then at least once a day it gets exported to the public one. That sounds more like a technical detail where you commit it first and then export it, but that has a lot of consequences. In particular, since you first push to open, we want to first push to the public repository, that means the interfaces need to be well defined. You can't do it at the moment. You just import internally, run all the internal tests that you care about, and then see whether something fails. That is a big commitment, saying you need to get the interfaces well documented and well tested, because still Google is using the tool and can't afford having the engineers not have a build tool for a longer time. And to be a proper open source project, we also want all the design reviews in public. We're working towards that, but there's still some use cases which are Google only, and so sometimes things come up, but there is more and more going in the direction of having generic interfaces and open design reviews. Oh yeah, and at the moment it happens that the whole core team are persons employed at Google, which is, for a true open source project, we hope to also extend that base. And as I said, prerequisite for all that is to get things stable and well documented. And while that is the big goal, where we're aiming for, there are a lot of kind of technical improvements that we hope to solve on the way there. For example, we'd like to improve the remote execution API. I said remote execution is very powerful, especially if you can share caching between different persons working on the same code base. So Bazel, I hope I'm not saying something wrong, does have an remote execution, does have an API and a prototype implementation, but we hope to make that a more standard API that is well documented and used by a lot of people, and get out of this prototypical state. And as I said, for it to become a community project and to be a generically useful tool, we aim to get more repositories of specialized build tools for languages which aren't that important within Google, and hope that there's a community contributing, or there is a community, and we hope that this increases and there's a good collection of rules, so that Bazel can become more a language agnostic tool that knows how to organize compiling, how to do caching correctly, dependency tracking, and have a specialized knowledge about individual programming languages in a separate place. And the other thing which there's currently work going on is improving the story of remote repositories. As said, that is something that only became an issue with open sourcing. As within Google, there is only that one repository. I mean, it's working. You can specify remote repositories as a dependency in your build file. They get fetched, they get compiled. But there are a lot of things to improve. In particular, recognizing if you fetch something in the hash value, or the declared hash value hasn't changed, it doesn't matter that you're now fetching it from a separate place, you still can cache it, or even saying, yes, we know these are the artifacts coming out of that remote repository, I don't even need to recompile that if the repository hasn't changed. Then what about recursive remote dependencies? If some remote repository depends on another remote repository, and what if two then point to the same thing? So it is working in principle, but there's a lot of more improvements to be made, and we're working on it. And a lot of small details. Also, something which I didn't mention on the slide, but is also very big, is other platforms. So making sure Bazel runs well on iOS, on Windows. Windows especially is a lot of work going on. And yeah. So to sum up, what are the approaches of Bazel? It has a declarative approach, so you say what you want to build and then have a separate place where you have the knowledge how to build it. You really track all the dependencies, including tools, including things that are implicitly read by a tool. And that is what ensures correctness, and you have some support to help you really know what you're reading, so the handboxes. And that full knowledge enables fast builds because you can more aggressively cache, you can execute remotely very easily because you know what is needed, and can share that between different people working on the same code base. And it is open source, and the plan is to commit, and there is some commitment to that, and the plan is to get a fully useful open source tool. Or it is already useful to, but make it a more community project, not a project dominated by one company. And you're invited to try Bazel yourself. So there's a homepage, the whole code is at GitHub. There are two mailing lists, one for people who just want to use the tool, and a separate mailing list for discussion on how to extend Bazel further, how to develop it. We have an IRC channel, and yeah, at least all release artifacts are signed. And pretty fast, so that is the end of my presentation, and I'm here for questions. And we also have a stand next door where you can meet the Bazel developers today and tomorrow, the whole day. Thank you.
Hello, thank you for the presentation. Are there any plans on making Bazel more modular? Right now it's one big binary file which contains a lot of dependencies. It's 100 plus megabytes. I know this could be necessary for the to make it reproducible, but
so I'm not sure what you mean by more modular. So the code itself is organized in a modular fashion. There's also an internal interface where you can add more functionality. And another thing that goes in the direction of modularity is to get more of the specialized knowledge out of the tool into files describing builds. That it probably will always be a kind of biggish binary. And we certainly won't get rid of the dependencies of the JVM to, is this written in Java, you could say that. Or what precisely do you mean with more modular?
I mean more modular in the sense that so you can remove a lot of the bundled dependencies that's in the binary. I know the reason why the binary is so large are that...
the built-in things here. There are some plans in that direction, but I don't think they are the highest priority at the moment. So there are plans to make it a more generic tool and not bundle everything, but on the other hand, it's very useful if you have one binary that just works, which also makes deployment easy, and that is a big thing. But there are plans in that direction, but not very much. I think there were other questions. Yeah.
Thank you for your talk. One question is, as you said, it's a tool with a history. Why did you decide to open source it now and not like 5 years ago? Was there a particular reason? And another one, will we see Android and Chrome using this tool?
Okay, let's start with the answer to the second question. Yes, Android development. Well, you can know the roadmap better than feel free to ask.
So we are talking to the Android teams and the Chromium teams. If you look at the Android source code, there is actually now there are build files in there. Not all of the SDK is currently built with Bazel, but we hope that we'll get there. We'll see. For Chrome, they have built a lot of their own infrastructure. They use remote execution extensively. Our remote execution story is not stable yet. So it will take a while before we're at a point where they could switch over, but we certainly hope that that will happen eventually.
And the question why open sourcing now and not earlier, that's you know better because I joined the team only a year ago, and I'm happy that I could join an open source project because I like working the open source and having contact with external contributors. But
okay, why now? It sort of seemed to be the right time. There are things I can't talk about.
Hello. How does it identify the toolchain it's using, and how does it detect changes in the toolchain for C, for example? Sorry, I'm over here.
okay, so
Excuse me, everyone. We're still running the session. It's question and answer. If you could keep it more quiet, we would appreciate that. And if you want to leave, if you could leave quietly from both sides. Also, if you could repeat the questions for other people, that would be good.
because the other microphones is not.
Yeah, if you could repeat the question.
Okay. So then the question was how does Bazel identify changes in the toolchain? To be fair, it wouldn't notice if you change the content of the compiler that is an external, but the toolchain as declared, there's a declared toolchain, even if you don't do it explicitly. Internally, Bazel knows which compiler it did use, which libraries. Also, if you know better, you can also correct. It's always a declared set of tools that are to be used, and a declared target, and that information is kept into the graph, and if that declared compiler changes, then all the actions get invalidated and have to be done with the new toolchain. So it's not, as far as I know, it doesn't track the value, the content of external tools. So if you just happen to sneak in a new compiler, then that wouldn't be noticed. But if you declare you want to build for a different toolchain, then that is noticed.
Okay, thanks. So you manually say, I'm going to use GCC 5.4, for example, and then if you change that, then it recompiles everything.
Yeah, so I don't know how it works.
How does Bazel work together with external dependencies and build things like got for Java, we've got POMs, we've got NPM, and all these things.
Okay, so the question was how Bazel works together with external dependencies, in particular specialized ones for languages. So what you can declare is saying this is an external source tree or an external repository, or by various means download it as a Git, specified Git hash, download it as a file and check that it better has that hash value. And you can also drop in a build file. But it doesn't have built-in knowledge about the various packaging formats. It has some generic things. It knows what the Java archive is, it knows what the zip file is, it knows the tar archive and so on. But beyond that, you have to describe how you build it. But you can drop into a given source tree your own build file that then has a specialized information in that source tree doesn't bring build file. So you can at least version them separately. Yeah?
Okay, two quick questions. So the first one is that it's implemented in Java, right? So
yes, Bazel is written in
So
Java.
what if you have a project where you need to compile it on a platform where Java is either not available or there's not resources enough to run it?
Sorry, it didn't...
What if you need to have a project where you need to compile on a platform where Java either is not available or it's too big of a dependency, it doesn't run properly on the machine?
So the question was, what do we do if Java is not available? So Bazel itself is written in Java, so on the host platform you need to be able to run Java full stop, otherwise you can't run Bazel. But if you have a cross toolchain, you can cross-compile for a platform where you don't need to run Java if the program you're trying to compile isn't written in Java, obviously.
Okay, so the second question is more about, okay, so does committing code into Bazel require signing a CLA?
Sorry,
Does contributing to the code require signing a CLA?
Yes.
Contributing
to Bazel requires a CLA, signing a CLA. So that was the question. The answer is yes, it does. And yeah.
So,
but the code itself is under the Apache license. So if you say, yeah, you don't want to cooperate with Google, technically have the ability to fork in. So I would prefer to have it as contributions to the project.
So one question here. It's here.
Okay.
Down here, yeah. Hello. So how do you implement the sandboxing and the parallelism? Isn't a separate process that runs for each action and some form of MPC between the actions?
Okay, so good question. Yeah. So how do we implement sandboxing in detail?
Okay, so the sandbox on Linux, we use a user namespace, and then we create a mount namespace and a network namespace, and then we set those up to show just the files that you have declared. And it effectively runs as your user, but the rights work out in some way. On macOS, we use the existing macOS sandboxing mechanism, which you probably know about. On Windows, we don't currently have a sandbox, but we hope to add that at some point.
We have a question at the back.
Hi there, thanks for the talk. So I was wondering, at the start of your talk you mentioned that at Google there's a source tree that has 10 to the power 7 source files in it, which is quite big. That also means that for more complex applications, the dependency graph, like the dependency graph itself would already not fit in memory. How does Blaze deal with that? Is there like some graph partitioning, or does it only like partially evaluate the graph? Or
so the question was, what does Bazel do if the dependency graph itself doesn't fit in memory? It assumes it fits in memory, and it only looks at the part of the dependency graph that you need for your target. So you don't look at the whole repository, only your target, and then recursively discover what other files you need. But the approach is to hope that it will always fit in memory, and then have big enough memory.
Hi. Is it possible after all the building is done to use Bazel to generate some Docker images ready to deploy with all our binaries and the dependencies?
So the question was whether Bazel can build Docker images or use Docker images.
No. After we have all the building done, then to package our binaries and libraries into some form of a container or packages like RPMs or webs.
So Bazel. So the question was, can Bazel package the artifacts created? And the answer is Bazel has knowledge about certain package formats. As far as I know, definitely including Docker, Debian packages, NPMs, and, well, tar archive, obviously. And I'm not sure which else is already existing, but the plan is if there are more packaging formats needed, then to better have that as an extension instead of compiling more specialized knowledge into the original binary. But, I mean, whenever you know how to build a binary, you can also use the generator artifacts to get a new artifact which is then the package. That's just an artifact as any other artifact.
You said one of your goals was the support for Windows, but you said you could use Bash in your extensions. How does that fit with your goal of supporting Windows?
Okay, so the question was based on Windows and how does it fit with, you have rules that explicitly call Bash. I mean, you can only, of course, you always need the tool chain to be present at the target. So there is something like, well, there is Bash for Windows, and if you want to write a rule in Bash as your build language, as your compile language, then you better install Bash. But there are plans to have rules that are specific to a language, like compiling C code, done that with a native tool chain. But if you need a tool, you have to have it on the machine where you're building. There's no magic way around that.
There's a question over there. Over there. We will have one more question after that. So
thank you for the talk. What is the status of IDE integration like IDEA or Eclipse?
Oh, status of IDE integration. You know better because I only use plain Emacs and command line tools, and that works.
Of course.
But there are.
So we have an experimental plugin for Eclipse. We have a supported plugin for IntelliJ, which also works with Android Studio. We have an Eclipse for Xcode. We don't a plugin, sorry, an Eclipse for Xcode. Okay, we have a plugin for Xcode, which is also supported. We are looking at providing a plugin for Visual Studio as well, but currently our focus is to make Bazel work really well on Windows first before we start integrating with IDEs. We don't have any plans for NetBeans right now, but feel free to contribute.
There's no more question. So it's right on time. Thank you, everyone.